Math lesson number 42. If-then statements. An if-then statement is a statement in the form of if-then, which expresses condition. It is also called a conditional statement. Let's have an example. If an angle is acute, then its measurement is between 0 degree and 90 degrees. So as you can see, there is this if part and then part. So this is the conditional statement or if-then statement. In the example, if an angle is acute, then its measurement is between 0 degree and 90 degrees. An angle is acute is called the hypothesis. So this part here, an angle is acute, that's the hypothesis. And is represented by P. Its measurement is between 0 degree and 90 degrees is called the conclusion. So this part here is called the conclusion, which is represented by Q. So in short, the conditional statement is represented by if P then Q symbol. Tell whether each of the conditional statements is true or false. Number 1. If two angles are congruent, then they are vertical angles. This is false because not all congruent angles are vertical angles. It is possible that the two angles are congruent but not vertical. Number 2. If two numbers are even, then their sum is also even. Is this true? Yes, this is true. Any two even numbers, when added, will result to an even sum. So the statement is always true. Counterexample statement is a statement used to justify that a given conditional statement is false. It could be a figure, an explanation, or a situation. Let's have an example. Conditional statement: if two angles are congruent, then the two angles are right angles. Of course, this is false. Let's have the counterexamples for this statement. Number 1, there are acute congruent angles and obtuse congruent angles. That's why the conditional statement is false. If two angles are congruent, then they can be vertical angles, which may not be right angles. That is why the conditional statement is false. Again, counterexamples are statements used to justify that the given conditional statement is false. Different forms of statements related to conditional statement if P then Q. Number 1, converse statement. It is a statement wherein the hypothesis and the conclusion are interchanged. In symbol, if Q then P. Let's have an example. The conditional statement: if the sum of the measures of the two angles is 90, then they are complementary. Converse: if the two angles are complementary, then the sum of their measures is 90. So as you can see, the hypothesis here becomes the conclusion. That's the conclusion. And the conclusion here in the conditional statement becomes the hypothesis. That is converse statement. If Q then P. Number 2, inverse statement. A statement wherein the hypothesis and the conclusion are both negated. What does this mean? So the original statement, if P then Q, will be turned into if not P then not Q. So that's the symbol. If not P then not Q. Let's have an example. The conditional statement: if the sum of the measures of the two angles is 90, then they are complementary. Inverse statement: if the sum of the measures of the two angles is not 90, take note, negation, not 90, then they are not complementary. So the hypothesis being negated is not 90. The conclusion is also negated. They are not complementary. So this is inverse statement. Number 3, contrapositive statement. A statement wherein the hypothesis and the conclusion are both negated and interchanged. In symbol, if not Q, then not P. So as you can see, in other words, contrapositive statement is a combination of converse and inverse. Let's have an example. Conditional statement: if the sum of the measures of the two angles is 90, then they are complementary. Contrapositive: if the two angles are not complementary, take note, if the two angles are not complementary, then the sum of their measures is not 90. So as you can see, the converse and the inverse are being combined to have a result of contrapositive statement. Number 4, biconditional statement. A statement in the form of P if and only if Q, which is only true if the conditional and converse statements are both true. So in symbol, P if and only if Q. Example: conditional statement: if the sum of the measures of the two angles is 90, then they are complementary. Biconditional statement: the sum of the measures of the two angles is 90 if and only if they are complementary. So once again, the sum of the measures of the two angles, that's the hypothesis, is 90 if and only if they are complementary. They are complementary is the conclusion. That is biconditional statement. Now, the conditional statement is if the sum of the measures of the two angles is 90, then they are complementary. This is true. The converse statement of that is if the two angles are complementary, then the sum of their measures is 90. This is also true. Let's have the biconditional. The sum of the measures of the two angles is 90 if and only if they are complementary. Now, since the conditional statement is true and the converse statement is also true, then the biconditional statement is also true. So once again, the biconditional statement is true if and only if the conditional and the converse statements are both true.